Welcome. We are going to find the minimum sum of products for f using Karnaugh map. F is written in three forms for illustration: the min-term expansion, or the standard sum of products, the max-term expansion, or the standard product of sums, and the truth table. The values of AB are written in the sequence 0, 0, 0, 1, 1, 1, and 1, 0. And in the same sequence we write the values of CD 0, 0, 0, 1, 1, 1, and 1, 0. For this square, the values of AB and CD are 0, 0, 0, 0. And this is equivalent to 0 in the decimal notation, so we write 0. For this square, the values of AB are 0, 0, and CD 0, 1. 0, 0, 0, 1 is equivalent to 1 in the decimal notation, so we write 1. We can follow this sequence when we fill the Karnaugh map: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We can use any one of these three forms to fill the Karnaugh map. When we use the min-term expansion, we place 1s in the squares that carry these numbers, and we place don't cares in the squares that carry these numbers. When we use the max-term expansion, we place zeros in the squares that carry these numbers, and we place don't cares in the squares that carry these numbers. And when we use the truth table, we place 1s, zeros, and don't cares depending on the values of A, B, C, and D. For example, here the values of A, B, C, and D are 0, 0, 0, 0, which corresponds to this square. The value of f is 1, so we write 1. The don't cares are represented by x's. Now we group the adjacent squares that contain 1s and x's. The number of squares in these groups should be a power of 2. For example, 2, 4, 8, or 16, and so on. And the priority is given to the largest possible group. Here we have a group of 8 squares. Here we have 4 squares. And this group contains 2 squares. This expression represents the minimum sum of products for f. Each term in this expression represents one of the groups. For example, C represents the blue group. C is derived from the blue group because the blue group contains both the A prime and the A columns. So we eliminate A, because when the group contains both the variable and its complement, we eliminate that variable. Now we check B. The blue group contains the B prime and the B columns, so we eliminate B. And it contains only the C rows, so we write C. And it contains the D and the D prime rows, so we eliminate D. A represents the red group, because the red group contains the A columns, so we write A. Now we check B. It contains the B and the B prime columns, so we eliminate B. Now let's look at C. It contains the C prime and the C rows, so we eliminate C. And it contains the D prime and the D rows, so we cancel D. And in the same way we can find the expression for the green and the pink groups. And we get this expression. This is another example about Karnaugh map. We can see that f has only 4 zeros and the other values are ones. So it's easier if we write the zeros in their places as shown and then fill the other squares with ones as we can see here. Now we group the adjacent squares that contain ones and this is the minimum sum of products for f. C is derived from the blue group because it contains both A prime and A, so A is eliminated, B prime and B, so B is eliminated, C, so we write C, D prime and D, so D is eliminated. And this term, which is D, is derived from the red group because the red group contains A prime and A, so A is eliminated, B prime and B, so B is also eliminated, C prime and C, so C is also eliminated, and D, so we write D. This is another example about the Karnaugh map, but here we want to find the minimum product of sums for f. So the first step is to fill the 16 squares with their values. In these two columns, the value of A is 0. But here we write A instead of A prime. And the value of A in these two columns is 1. But we write A prime, which means the complement of A. Now we group the adjacent squares that contain zeros, as shown. And this expression represents the minimum product of sums for f. The first term, which is C plus D, is derived from the blue group because the blue group contains A and A prime, so we eliminate A, B and B prime, so we eliminate B, C, so we write C, and D, so we write D. And this term is derived from the red group. Thank you very much.